OpenAI hasn't announced that Astra possesses a critical cyber capability. What it has announced is something much harder to act on. Its tests couldn't rule one out. So, what would actually count as proof that a model can't do something dangerous? That distinction is the whole story here. OpenAI is slowing Astra's development and expanding its safety testing because internal evaluations couldn't rule out critical cyber capabilities. Based on the supplied finding, this isn't a confirmed positive result. We don't know that Astra has the capability. What we do know is that the available evaluation evidence wasn't strong enough to confidently conclude that it doesn't. Picture two doors. Behind the first is one question. Did the evaluation find a dangerous capability? Behind the second is a tougher question. Would this evaluation have found the capability if it were present? A convincing positive result may be enough to answer that first question. But a clean result doesn't automatically answer the second one. Say a test runs and produces no confirmed failure. That result could mean the capability is absent, but it could also mean the evaluation didn't cover the right conditions, wasn't sensitive enough, or simply failed to expose what the model could do. Those are analytical possibilities, not claims about Astra's specific tests. The key point is that not observed and ruled out are two different conclusions. And that's why expanding the testing is a rational response to uncertainty. OpenAI is slowing Astra's development and testing further because the existing evaluations couldn't rule out critical cyber capabilities. The additional testing isn't, on its own, evidence that a dangerous capability was discovered. It's an effort to improve the evidence available for making the decision. The basic logic is pretty straightforward. You begin with an unresolved question. You design additional evaluations intended to produce stronger evidence. What we can't infer from the supplied finding is exactly how those evaluations work, which scenarios they include, or what Astra did in any individual test. But the decision principle is visible. Uncertainty prompted more scrutiny instead of being treated like a clean bill of health. So why allow uncertainty to slow development at all? Because the capability being considered is described as critical. When the possible consequence is serious, unresolved uncertainty can carry real weight in a decision, even before anyone confirms a failure. That shifts the practical question. It's no longer just, have we observed a dangerous capability? Now it becomes, does the evidence support proceeding despite what the evaluation may have missed? Both questions rely on the same test results, but they impose different burdens. The first looks for a positive finding. The second asks whether the complete body of evidence is dependable enough to justify action. None of that means every uncertain result proves danger. It doesn't. Uncertainty isn't confirmation. Still, uncertainty can affect a decision when the unresolved capability is consequential. Astra's slowdown illustrates that uncomfortable middle state. There's neither a confirmed dangerous capability nor enough confidence to rule one out. Here's where the burden of proof problem comes in. A claim that a model can't perform a particular task is only as strong as the evaluation supporting that claim. To justify that negative conclusion, evaluators need evidence that meaningfully constrains the model's possible capability. That puts test coverage and test sensitivity right at the center of the argument. Coverage asks whether the evaluation explores enough of the relevant space. Sensitivity asks whether the evaluation would reveal the capability if it were there. If either one remains uncertain, a clean result may still be weak evidence. The capability might never appear during testing, and yet the evaluation still might not justify the conclusion that it's absent. Think about a detector connected to an unknown signal. If that detector stays silent, there are at least two broad explanations. Maybe there was no signal. Or maybe the detector couldn't reliably register it. Before silence can become proof, you need confidence in the detector itself. In model evaluation, that confidence has to come from the strength of the testing evidence, not simply from the fact that somebody completed a test run. And again, this analogy doesn't tell us anything about Astra's specific methods. Those details weren't supplied. It simply makes clear why proving a negative is structurally difficult. A positive result can establish that a capability appeared at least once. A negative conclusion has to address the possibility that the evaluation failed to bring that capability into view. So Astra changes the safety conversation in a subtle but important way. The headline isn't that OpenAI confirmed a critical cyber capability. The verified finding is that OpenAI slowed development and expanded testing because its internal evaluations couldn't rule such capabilities out. That puts the quality of the evidence at the center of the decision. A safety process can't look only for confirmed failures and then treat every other outcome as equivalent to safety. It also has to ask how much confidence a clean or inconclusive result really deserves. What did the evidence actually establish? What's still unresolved? And is that remaining uncertainty acceptable for the particular decision being made? This is an evidentiary problem before it's a verdict about Astra. Expanded testing signals that the current evidence wasn't considered sufficient to close the question. It shouldn't be reframed as proof that the feared capability exists. The careful interpretation falls between those two extremes. The capability remains unconfirmed, but its absence remains unproven as well. So, what would qualify as proof that a model can do something dangerous? It wouldn't be simply a test where the behavior failed to appear. The evidence would have to meaningfully constrain what the model could do and provide confidence that the evaluation would have exposed the capability if that capability existed. That's the answer Astra's slowdown brings into focus. No confirmed failure isn't the same thing as proof of safety. At the same time, being unable to rule out a capability isn't confirmation that the capability exists. The consequential fact is the gap between those two conclusions. When the capability at issue is critical, that gap can be enough to justify slowing down and collecting stronger evidence. The Astra problem isn't simply about whether testing finds danger. It's about whether the evidence is strong enough to support a claim of safety when the consequence of getting that claim wrong is critical. If you value careful analysis of AI, software, and open source, subscribe to NeuralStack and tell us in the comments, what standard of evidence should a critical capability evaluation have to meet?